So for this problem, we have three charges which are situated at the corners of a square with size A. And we want to figure out how much work is done to bring the other charge plus Q in from far away and place it in that fourth corner. So first, I'm just going to redraw the diagram. So we have our four charges, or our three initial charges. So negative Q plus Q, negative Q. And we want to bring a positive Q to this point. And we're just going to name that point A at the moment. And we know the size of these are A. So we know the distance between all of our charges except for point A, where that plus Q charge is going to come in, and the other plus Q charge on the other side. So we need to figure out that. So we have R is equal to A squared plus A squared to find that distance, which simplifies to the square root of 2A squared. And we know that's just A times the square root of 2. So that's our distance here. And we can just call that R. So now we know we have to find our potential first so that we can then find the work. So we have V of R is equal to Q over 4 pi epsilon naught R to find our potential. So we go ahead and plug in what we have from our setup. And like I said, we're going to name this point A. So V of A is simply equal to 1 over 4 pi epsilon naught. And then our charge Q is going to be the sum of all our charges. So we have that negative Q charge over A, which is the distance, plus the Q charge that we just found the distance to, which is A square root of 2 minus Q over A. So now that we have that, we can further simplify it. So V over A is equal to 1 over 4 pi epsilon naught A 1 over root 2 minus 2. And so we want to bring the charge, like you said, from a very far distance. So we just gonna say that the work bring it in the fourth charge, that plus Q charge from infinity. So we have V of infinity is equal to 0. So now we want to use our work equation. We know the potential at infinity is 0. V of R minus V infinity. Now we just have to, we know that this is 0. So now we have to find V of R, the potential of R, by substituting 2A in for R in our equation. Well, square root of A times 2 in our equation. So we have VR equal to Q over 4 pi epsilon naught R, as we wrote out before. So that means VR equal to Q over 4 pi epsilon naught times A root 2. Therefore, work is equal to Q squared over 4 pi epsilon naught A 1 root 2 minus 2, using our potential that we just solved for. And that would be our final work. Now, for part B, it wants us to figure out how much work is done. How much work does it take to assemble the whole configuration of the charges? So again, we want to use our work equation. We have work is equal to Q over 4 pi epsilon naught. Then we have our charges. So we have the negative Q charge plus negative 2 charge plus 1 over A root 2 plus a negative Q charge plus 1 over A root 2 minus Q. So those are 3 charges. Then we have work is equal to 1 over 4 pi epsilon naught Q squared A. We have negative 1 plus negative 1 plus 1 over root 2 plus negative Q plus 1 over A root 2 minus 1. So we can solve it a little further and get work is equal to 4 pi epsilon naught Q squared over A square root of 2 minus 4. And that will be our final work being done to assemble the whole configuration of the 4 charges. Thank you for watching this video.